We will review a paper on learning general purpose distributed sentence representation via large scale multitask learning by Sandeep, Adam, Yosho Banjo, and Christopher. For the introduction of this paper, has been plethora of research around word representation trained on large text corpuses, but learning representations for sequence of words such as sentences remains still an open problem. So, in this paper, the authors have presented an effective multitask learning framework for sentence representations that combines the inductive biases of diverse training objectives in a single model. So, the state of transfer learning in machine learning, particularly in computer vision, CNNs have been able to use a lot of pre trained models from ImageNet in various end objectives like image captioning as well as facial question answering. But in NLP, tasks have benefited fundamentally from word embeddings, which is either fixed or fine tuned for each application. So, in this paper, the fundamental idea the authors have been proposing is that there are multiple tasks which are trained separately, like skip thought vectors or machine translation or neural language inference, as well as constituency parsing. And all these tasks actually have different inductive biases. Now, if we can build a model where we share a sentence encoder among different tasks, and we try to minimize the objective function of all these tasks in a multitask learning setup, then there is a fundamental chance that we can learn more robust representations of the sentence, which can even work for unseen tasks as well. So they have proposed training a single encoder representation for multitask based objective. And so they have used these four tasks for their training and different training objectives as well as different data sets whose sizes have been given on this particular table while training their encoder model. So they've set up this multitask learning problem as follows, where they have k tasks, and then they schedule these tasks accordingly based on some probability, and they try to go from one task to another and try to minimize the different objective functions while sharing the same encoder function for their sentence representation. And after the training, they have also done some sort of visualization to see what kind of representations they are able to learn from on their shared encoder. So this visualization show what kind of clusters the encoder representation is able to capture in terms of the vectors. In terms of the results, they have shown some positive results in terms of MRPC dataset and CKLR datasets. Also, they have tried using their encoder representation into Quora question answering pair problem, and they have shown some positive results from the combined encoder output. And if you guys want to more know about the paper, you can go to this link and read more about the experimentation section as well as the multitask objective.